Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and in this lesson I'm going to cover a little bit more about the typedef keyword. I mentioned it in another recording with regard to structures, but I'm going to use it here in a much more general way for the built-in types like int and float and character. Now, you may be thinking, well, int, float and character are perfectly good terms for describing exactly what they do, so why would I want to call them something else? Well, there is actually a very good reason, particularly when it comes to embedded systems and when it comes to having computer programs that are portable from one system to another. So if I write a C program and I write it for the PIC microcontroller and I then want to move that C program to the 8051 microcontroller, or perhaps it's a Motorola chip or something like that, then the chances are that it's not going to run perfectly smoothly and that I'm going to have to make changes. What we want to do is we want to write our programs in such a way that we have to make the minimum number of changes possible. Now, one of the problems that we face is the idea of the types not exactly keeping their sizes. And what I mean by this is that the size of an int is not consistent from one platform to another. So on the PIC or the 8051, you may find that an int is 16 bits in size, but on the PC that I'm currently working on, it's 4 bytes or 32 bits in size. Okay, and yet they're both called int. And that means that if I assume that the int is 32 bits in size and I then move it to another system where it's 16 bits, things can start to go wrong. So just to show the sizes of the different things, what I'm going to do is I'm going to do a printf. So I will say int is %d bytes. And into that I will put size off, so the size off operator, and I will put an int in there. Okay. So let's just look at what that prints out. Okay, we can see that an int is 4 bytes in size. Now, you may remember that there are some other things as well that we're used to seeing, such as the character. So we'll say char is %d bytes /n size of CHAR. Okay, and we'll create a few more of these. I think I have one too many brackets in there. So, okay, so around the int, there are some other options that are available to us, such as the short, which is a shortening of short int. Okay. Now, what we find is in the definition of short and in the definition of long, it's that on a platform, int will be either the same size as short or long, but it's dependent on the platform, not on the, it's not something that's inherent in the language. So we kind of need to check these things out in order to be sure. So I'm going to check out how long a long is as well. Okay. So let's try all of these and see what we come up with. And I'm missing a bracket. Okay, so we see an integer is 4 bytes, a character is 1 byte, a short is 2 bytes, and a long is 4 bytes. Now, as I said, what we prefer in many situations for portability purposes is that we knew exactly how long the data was that we were dealing with, and that if we moved to another system, we wanted to maintain that length. Now, we can never have it that if we move to another system, it will maintain that length. But what we can do is we can try and minimize the number of changes that we want to make. And we do that by typedefs. So I can say something like type typedef int, and I'm going to call this u. Actually, what I'll do is I'm going to make an unsigned int, and I'll call this u int 32. Okay, we'll make one for a non-signed one. For a signed int, which we'll just call int 32. We'll also, and that says typedel instead of typedef. And what other ones will we do? We'll do unsigned char. Now what I'm going to call this is uint 8. And that's now one of the things that students often have trouble with is the idea of using a character or a char variable as just a number between 0 and 255, because you have a tendency to think that it's got something to do with a letter, whereas in actual fact it's just a small variable that can hold a number between 0 and 255. And because we can hold all the ASCII characters between 0 and 255, the character turns out to be a very good way of holding actual letters. But if we want to use it as an integer and think of it as an integer, then it makes more sense to do it that way. Now you'll notice as well, and actually what I'm going to do with this one is I'm going to put an I on it, a capital I on it. As I said, normally a good idea to capitalize these things so that we know that they're or that we stick to the kind of convention that they begin with capital letters. So sorry, rather than making a non-signed character, this is what happens when I talk and type at the same time. I make mistakes. So this would be just int 8, and obviously the 8 suggests how many bits that are in it. A few other ones then we can do are unsigned long. So we noticed previously that the long and the standard int were actually the same length, so there's no need for me to make a standard integer one as well. Now, there's no guarantee that when we move to another system, well, actually I've already done those above, so I've just recreated them again. So it's the short is what I meant to do. So unsigned short, because I had done the int above, and I could have done that as a long either. So I'll do a one for 16. Now we may find if we move to another system that the integers are not 4 bytes in size as we expect them to be here, and that you have to write long in order to get a 32 bits in size, rather than bytes. And we may find that a character is not that length, or we may find that a short is not the length it is here. A short may be 8 bits or 1 byte in size, and so on. However, the point is that if we use them later, all throughout our program, and remember we might write a program that is thousands of lines of code, 10,000 lines of code, more than that. We don't want to be going through and changing each one of them individually. So instead what we do is we only have to change this little piece of information up here, so that we then match up and make sure that the right type of typedef attaches to the right size. And from then on, we know that it's that particular size. So just to look at these ones here, I'm going to try, I just call this uint 32 is %d bytes, and we'll put in for char, I'm going to put in uint 8. And these names, I'm getting them uint 8 and so on, things like that. They are kind of standardized, but I only say only kind of, because there are different ways of writing them. You don't necessarily have to put in an underscore and things like that. So strictly speaking, you can call them whatever you want, but try and keep them something that actually makes sense, that is readable. So it's fairly obvious from uint8 that that's going to be an unsigned integer that's 8 bits in size. For the short, we're using the uint16. And again, we're going to use the uint32. I must have hit the insert key there. You may find this sometimes happens where it starts overwriting text on you. And it's normally the insert key that has caused it. So, which is in the little set of 6 keys. If it's on a standard keyboard, or on my laptop, it's the second from the top left top right. It's beside the delete key. And what happens is if you accidentally hit that, you'll notice that down here at the bottom where it says insert, that changes to overwrite, and it starts overwriting text. So it can be a bit of a nuisance. As you can see, it's done it to my previous one as well. Okay, so we're doing them twice. I've missed a bracket here, as you can see, just to trace that error to where it is. It's on that line, and it's saying that we're expecting another bracket, and it's correct to expect another bracket because I'm missing one. And then on the same thing, it's saying that there's something wrong down here, but that's caused by that initial mistake. So oftentimes, if you solve one of your errors, you solve the others. Conflicting types, uint16. Oh, that's true. I should have just called that int16. Okay, and we can see 4 bytes, 1 byte, 2 bytes, and 4 bytes coming up for those. And again, the fact that I've used the U's in here, I could have changed those to the I's. The numbers will be signed or unsigned. And so that means that now, as you know, obviously that all I've done is shown you the size of them there. But if I want to create variables, I literally just say uint underscore 32x, or I can say int underscore 16 and call it y. Okay, so that's all I have to do there. Sorry, that should be a capital I there. And what I'll do is here, I'll take away 2 of these printfs, and we'll just look at the size of these. Actually, I'll make a third one. So I'll take away 1 of the printfs. So I'll do another one. I'll just make a character uint8, and I'll call that C just because it's a character. So uint8 is %d, so I'm going to say C, and rather than size off uint8, I'm going to get the size of C. Here we'll say y, and again we'll get the size of y and check if it's correct. And I'm going to go for x here, and we'll put in x in this case. Unknown type int16, and that's because I've accidentally put a lowercase up here. Okay, so we'll change that. And we can see that C is 1 byte in size, where we've used uint8. Y is 2 bytes for an int16, and X is 4 bytes where we've used a uint32. Now the other thing to mention then obviously is that Y can hold numbers from minus 2 to the power of 15 up to plus 2 to the power of 15 minus 1. X can only hold positive numbers, and it can hold positive numbers from 0 up to 2 to the power of 32. And C can again only hold positive numbers because it's unsigned, so it can hold positive numbers from 0 to 255. So it's just another way of writing these, and you'll find that when you start to use embedded systems like the PIC microcontroller and others that use C compilers with them, they tend to do this sort of thing a lot. They don't write them up at the top of the C program. In general, there's one header file that you link to, or that everything else links back to, that holds these, and that means that when you then port your system to something else, you only have to go and modify those, and anything else that you write then from then on refers back to those and is set up for exactly the right type and the right size. And it means that any integers and characters and things like that that you've put inside in your program, you don't have to worry about those changing in size, as long as rather than calling them ints and characters and so on, you call them uint and int 16s and things like that. In other words, the typedefs are the names that you've given them. So rather than recreating these yourself, if you find a new system and you find a header file that has this information in it, you stick to that, because that means that you're then sticking to the same sort of things that other programs and other programmers using that system will stick to. And it makes it very useful then when it comes to porting to another device. Okay, so that's yet another use of the typedef.